Hello students. So this is the video on chapter 1 chemical reactions and equations. So first we'll try to understand what are chemical reactions. So here is the definition. A chemical reaction is a process where the reactant gets converted into a product which may be under an influence of a catalyst. A word equation shows change of reactants to products through an arrow placed between them. The reactants are written on the left hand side LHS with a plus sign between them. Similarly, products are written on the right hand side RHS with a plus sign between them. The arrowhead points towards the products and shows the direction of the reaction. Now, have a look over the types of chemical reactions. So, here are they. First one is combination reaction. Second one, decomposition reaction. Third, displacement reaction. Fourth, double displacement reaction. And the fifth one is redox reaction. Now, let us begin with the first type, combination reaction. Combination reaction is a reaction where two or more elements are compounds combined to produce one product of different physical and chemical properties. For example, element A when combined with element B gives out product C. Here are some examples of combination reaction that you can go through. Few I am reading for you, like 2Mg plus O2 gives 2MgO, or H2 plus Cl2 gives 2HCl, or we can go for iron when heated with sulfur means Fe plus S gives out FeS. So you can see these are all combination reactions example. Now the second type is decomposition reaction. A reaction in which a substance is broken down into two or more simpler substances is known as decomposition reaction. A decomposition reaction is opposite of combination reaction. A decomposition reaction takes place only when some energy in form of heat, light or electricity is supplied to the reactants. Now the next type is thermal decomposition, which is a subtype of decomposition. So, thermal decomposition, where we supply heat to carry out a reaction. See in this given example on the slide, lead nitrate decomposes into lead oxide, nitrogen dioxide and oxygen in the presence of heat. Now the second subtype of decomposition is electrolytic decomposition. Electrolytic decomposition is a chemical decomposition in which a single reactant is decomposed into more than one products or its constituents by the passage of electricity. And here is the equation. Twice of H2O where undergoes the process of electrolysis producing two molecules of hydrogen and one molecule of oxygen. Now the third type is the electrolysis of water only, it is given here. So here is the apparatus how we can arrange. There in the plastic mug, water is taken, and in this water few drops of sulfuric acid is also added to make it a good conductor, and two electrodes are immersed, and these electrodes are actually graphite rod which are connected to a 6 voltage battery. And you can see the bubbling, how bubbling is taking place and the gases are evolving. In one of the test tube you can see hydrogen gas will collect, and in another test tube collection of oxygen gas takes place. Yes, this is the third subtype of decomposition, and it is called photochemical decomposition. When a substance is decomposed in presence of sunlight, it is called a photochemical decomposition. And the excellent example of photochemical decomposition is decomposition of AgBr, silver bromide, which is photosensitive, breaks down into Ag and Br. Now the next type is displacement reaction. Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. Both metals and non-metals take part in displacement reactions. For example, reaction of iron nails with copper sulfate solution. Have a look over the diagram how the reaction is carried out. Initially, blue solution of copper sulfate is taken, and therein you can see iron nail is immersed. After some time, you can see on the screen the color of the solution has changed because chemical reaction took place, and now it is ferrous sulfate solution, and copper has been deposited on the surface of iron nail. And this is the equation we can write: Fe plus CuSO4 gives Cu plus FeSO4. Now the another type is double displacement reaction, or it is known as double replacement reaction. In a double displacement reaction, the cations and anions of two compounds switch places. It means they will exchange their places. Have a look on the dummy reaction. It is given first. AB is a compound. When reacts with CD, another compound, both are ionic since they contain cations and anions, are producing the product AD only by switching the places of their ions, and CB is another product. The reaction can be carried out in laboratory is AgNO3 plus NaCl gives AgCl plus NaNO3. Now the last type of reaction is redox reaction. According to the redox reaction, as you can see on the slide, reduction is removal of oxygen and oxidation is addition of oxygen. If so, this can be explained with the help of the equation also. Equation is CuO plus H2 in the presence of heat, means reaction is carried out at high temperature. Then you can see to the product side, means to the right hand side, Cu plus H2O. It means you can clearly see, and it is visible here, that the oxygen which was present with CuO to the left hand has removed, and now it is added with hydrogen, that is H2. So it is crystal clear that removal of oxygen is called reduction, where we will get the metal, and addition of oxygen is known as oxidation, and where we have got as a product water. I hope you have understood. Thank you.